Now let's have a look at a few more operations which we can do on arrays. One of the most popular one is map. So map is used. Map is a method which is available on arrays. So you can see that, let's say you have an array. Let's say arr is equal to whatever. Let's say 1 2 3 4 5. Now if you do arr dot, then you will see that then you will have this auto suggestion, this map thing is there. Now how it works, you see that map is used for creating new arrays from the existing ones. So we are trying to create a new array from this array. And how do we do that? We write a callback, give a callback function to this map. So here we give some function, okay, some function we are giving. And how do we use this function, callback function? Is that for a particular element, whatever we provide input to this, so e, then though that thing will be whatever is returned from this map function, that will be in the assigned corresponding to this e in the new array. So let's write something like, let's say const new array is equal to this thing, right? And for now, let's say we have got e and we have returned simply same element e, and let's print this new array. Okay. Okay, and let's print this original array also. So we'll see that actually both are 1 2 3 4 5. So and that is because we have not done any modifications. However, right now let's say we do something like e into 2. Then what will happen, that for each element 1 2 3 4 5 is coming, and the returned value from each callback function is 2 times that, and that's why the whole answer we will get is twice of that. So the new array is now 2 4 6 8 10, which is we are trying to multiply 2 to each of the elements of the original array. So now you are slightly understanding, right, that how this map thing is working. Map thing calls this callback function for each element. So it will call this once for first element, again it will call this for second element, again this will map will call this callback function for third element. It will do that for all elements, and every time this e is the element for which it is calling. So it is calling for 1, then this e will be 1. Okay, so you can print, you can prove that by printing this here. Let's say I am printing e here, then you will see that 1 2 3 4 5 will be printed. You see 1 2 3 4 5 is printed, which means that this callback function is basically running each time for a particular element, and map is providing that particular element for which it is running as e. And now it is your wish what you want to do with that value e. Whatever you want to do with that value, that you do, but finally you return some value, and whatever value finally you returned is mapped to this particular element, to corresponding to that it is put in the next element. So for 1 I am multiplying into 2, so in the new array instead of 1 it will be 2. For 3 I am returning 3 into 2, so in the new array instead of 3 it will be 6, whatever you are returning. So you understand, so this array is mapped to this array, and this is a completely new array, right? So whatever you want to, and you can understand that it does not have to be so you can understand, you can return anything. So let's say I return let's say some hello. Okay, then you see that 1 2 3 4 5 times hello is printed. So it does not matter what are you returning. Okay, how you are using this e does not matter. Ultimately what matters is that what are you returning. What are you returning, that is going to be the value used in the new thing, right? And if you want to use that value, that is well and fine. So let's say I want to create a template literal string where this thing is h and I am trying to use somehow e. This is like my just weird use case. Okay, and I'm doing something like this, then it will, what happens, that the new array is every element is a string where h and that element is there, right? So if I print this, then you see that h1 h2 h3 h4, you understand? So this new array is a completely new thing which is returned by map, and this e can be used to guide us that what that particular element should be there, and there is one-to-one mapping, that 1 is mapped to h1, 2 is mapped to, so you understand that map will always return an array which is of the same length as the original array. You understand? If there are 5 elements, then length of this is 5. If there are 3 elements, then the length is 3. You see, because it is essentially just one element per one element in the original array. So the length will be same always, right? Map always returns a new array with the same length as the original array. That is clear, right? And we will see that, yeah, we gave an example that and now instead of this, you could have used like a shortcut this thing also. So let's say I write e into 2. Okay, so it will be like a shortcut function, right? Arrow function. So this is fine. Now let's move to filter. Filter method is like map is a method. Similarly, filter is also a method. And if you again see here, then you will see that if you do something like dot filter, then you will see that, yeah, you are getting this suggestion filter. Okay, now you see that what are the input arguments to, so again it also takes a callback function. So you see that actually if you hover over it, then you will get a lot of suggestions that it takes this predicate, which is a callback function. And again there are some more arguments, which is like the second argument is index. Index means what is the index of the array. The third argument is the array. And again, these things you might not use it, but again if you use that, then you can take those things. So my point is that in map also, if you see, then you see that the second was index, third was array, right? So let's for map firstly write that. So for example, let's say I was saying that, yeah, there is a element e and I am printing that element, or let's say I'm simply returning that element, or let's say I'm returning e into 2, whatever, e into 2, yeah. And now I know that, yeah, it will be like this. But let's see that what is printed e. So I know that e will be printed 1, 2, 3. That is fine. But you can see that there are other things like I. And if you print I, the second argument, you will see that you will get the index. So index of 1 is 0, index of 2 is 1, index of 3 is 2. So the index is printed. So I is the index. It's just in the case you need, then you can pass the second argument to the callback function, and that will provide you the index for that particular element. Thirdly, you see the ARR, the whole original array is the argument in the third thing. You might never use this, but again, just for clarity, I am telling you that again this ARR I am printing, then every time it is giving me the original array on which it is running. Okay, just for clarity, let's say somewhere you need to check something on this array, so you might check directly here, but who knows, who knows that this is inside some other file, some module where you don't have access to directly this thing, right? And so you might, this third argument might be handy if you want to check something on this original array. So yeah, but most of the times you will just play with first the particular element, or maximum you will use index, okay, not more than that. And using element, you can create the new values which you want to generate. Okay, now I was discussing filter. So filter is also simply like similar to like that, and again here also you see that index and array is passed, but right now we will focus simply on the element, that how we can use this element to create a new array with some conditions. Now the filter behaves something like this, that what happens that when you pass a particular element, you have to return something from here, and for this particular element what you return, based on that it is decided that whether this particular value is being added in the final array or not. So filter is used to filter things. Okay, so which means that let's say I have this 0, 1, 2, 3, 4, 5, 6, these many elements are there, right? I want to extract something out of it, and by definition the new array might not be same length as the original array. It might be same, might not be same, right? Because I'm trying to extract some elements from this, right? And what is the logic of extraction? The logic of extraction is that if you return some truthy value from this callback function, then that value is added in the final array. So for example, let's say I return true, any truthy value you can return, right? Then that thing, that element for which it is running. So again, filter will also run this callback function. So if you want to prove that, let's not print the array for now, let's simply print this thing that it is calling it again every time for that element, right? You can clearly see that yeah, this ARR is 0 1 2 3 4 5, that is fine, but you can see that this 0 1 2 3 4 5 6 is printing. Okay, if I am having this 1 2 3 4 5, then you can clearly see that it is running for 1 2 3 4, which means that it is calling this callback function is being called by filter one time for every element, and whatever element for which it is called, that element is passed as the first argument. And again, using this e, you can create whatever logic you want, but doesn't matter how you create this logic. You can use e, you don't use it, doesn't matter. The final thing is that in new array, this e will be added if the final thing which you are returning is truthy, and this e will not be added in the final array when what thing you return is falsy. So right now, let's say I do something like this. So let me firstly give you an example, return true. If I return true and then I print new array, if I print new array, then you will see that you see everything is added in the new array also. But if I return false here, you see that nothing is added. So you understand what is happening. If you return, and again, if you return 0, the same thing will happen. Like 0 is falsy, right? And that's why nothing will be added. If you return null, then also nothing will be added because null is falsy. If you return, let's say hello, you understand, in map the exact value which you were returning, that value was coming in the new array. Here that is not happening. Here the value which is coming in the array is actually the original value only, but this thing what you return just is it is just used to decide that whether the e has to be added or not. So this hello does not make any sense, but let's say I'm returning hello. Now filter will say that, yeah, I don't know why are you returning me hello, I don't care, but I just want to see that whether this thing is truthy or falsy. If this thing is truthy, then that item will be added. Okay, so now if I run, then I see that again everything is added because hello is truthy. And again, if I pass empty string, then again it will be empty array because this thing. But this is not the main scenario, right? This is, I just showed you the extreme case. The real use case is that using e, I have to create some logic and decide that whether I want to add something or not something to the final array. So let's say I have this logic that I have to extract only even numbers, right? Then I can write some logic, right? Let's say e, I take modulus remainder with 2, and if the remainder is 0, then I know that this is even. And if this is even, then I have to add this. I want even numbers, and that's why I return true, because I want to add those numbers in the final array. And else, if that is not even, then I will return false because I don't want to add that in the final array, right? And now if you run, you will see that you are getting 246. So this is the real use case where filter is used, that instead of writing a for loop, iterating over all the elements and checking this condition, this simple callback function, it can be made more simple. I'll just show you in a minute. But the point is that you can say that what values you want, for that you return true. What values you don't want, for that return you false. Again, this doesn't need to be true, this doesn't need to be false. You can return any truthy or falsy values, right? Okay, let's say I flip the case. Let's say here I return false and here I return true. Again, this is straightforward because now I am saying that false, I'm returning false, which means that don't add even values. And in else, which is odd values, I'm returning true, which means that add odd values. So now if I will run, then I will see that odd values are added and even values are not added. Okay, so this is the use case. Yeah, something like this. Secondly, if I use, let's say, something like this, true and false. Okay, you understand? Now I'm saying that, yeah, this thing is true, then return true. This thing is false, then return false. Then why am I using if else? I can simply use something like this, right? Instead of writing that, I can simply return this thing, return this thing. Okay, this will also work. You understand why this will work? Because right now this thing is an expression, and I am saying that whenever this thing is true, then obviously the thing is will be written. This thing will be true, then true will be written. If this thing will be false, then false will be written. Then rather than writing this whole logic, you can simply return an expression, and that will also work, right? So for example, this will return true, even values, right? And if not equal to 0 or equal to 1, I can write, then that will give me odd values, okay? And again, you can write some other logic also, but the point is that you should be able to understand. So for example, rather than this also, you can write something like return, if this thing is true, then return true. If this thing is false, then return false. Okay, so this thing will also work. But again, the simplest is this one. Simplest is this one. But you write the simplest one only when you understand the complex one. That is the point. If you understand this thing, then you should definitely write this. Some people directly write this and they don't understand how this is happening. For example, let's say I remove this part, else part I have removed. Then what should be the answer, right? Still, the answer is 246. Why? You have to understand why it is happening. Because for even numbers, I am returning true. Returning true means add that. But why 135 is not added? Why 135 is not added? 135 is not added because it is not that we are not returning true and that's why it is not added. It's not like that. You have to understand it carefully, that 135 is not added because for 135 we are returning falsy value. And what falsy value we are returning? Here for 135 I am not going inside if I have reached the end of the function, end of the function. Then if you don't return anything, then we know that undefined is returned. Okay, which means that for 135 in this function, for 135 undefined is returned. But I am not returning anything, which means undefined is returned. And undefined is falsy. We know that, right? And that's why 135 is not added. Okay, you have to understand this carefully. So again, else if you are properly using and properly returning false, that is properly returning false, that is like best way to do that. But you have to understand these scenarios also, that what are you basically doing. And don't just have a blanket idea that this is I'm returning this, that's why it is returning. No, you are returning for 135 also, you are returning, and you are returning a falsy value, and we know that for falsy values it is not adding, and that's why that is happening. Okay, now let's take a slightly involved example. So this we already saw, right? The true false we are returning, right? Then it is taking the even numbers, right? So for example, let's say I add here 0 also, then it will give me all the 0 1 2 3 4 5 6. Let's say this is the array. Then I know that now 0 is also an even number. That's why my final answer will be 0 2 4 6, which is new array, right? If I tell you, if I return E, what will be the answer? Okay, what will be answer? So you can see that the correct answer is 246. Okay, and you have to understand why 246 is the answer, right? You can analyze it like just like this, that let's see all the things. You properly have to analyze that for 0, for 1, for 2, for 3, for 4, for 5, for 6, what has happened. Okay, so we'll see that one by one. What is happening is that for 1, right, for 1, for 3, and for 5, right? For these three things, actually we are returning undefined. We have to understand that, right? For 2 and for 4, we are returning E. What is E? E means that particular element we are returning, which means that for 2 we are returning true, 2, for 4 we are returning 4. Okay, for 0 and for 6 also we are returning 6, right? And for 0 also we are returning 0. Okay, so we know that if it is even, then we are returning that item, and if it is odd, then we are not returning anything, which means that we are returning undefined. Okay, now again, filter will say that I don't care, like why are you returning me 2 4 undefined? I don't care. I just have to see one thing. The final thing which you are returning is truthy or falsy. Just tell me that thing. 0 is falsy, and that's why it will be not added. You understand? Not added. And similarly, the same thing is for undefined also. Undefined is falsy, and that's why it is not added. All the undefined is falsy, that's why it is not added. 2 is what? 2 is truthy, right? 2 is truthy, and that's why it will be added. And the same thing will happen, that 4 is truthy, and that's why it is added. 6 is truthy, that's why it is added, and that's why the answer is 246. You understand? You have to be very careful that it is not the case that it was in map. In map, whatever you were returning, that was added in the array. Here it is not like that. Here you can clearly see that 0 I am returning, but 0 is not added. You can clearly see that, right? And that is because it is not that it takes that value and simply adds it. It simply sees that it is truthy or falsy. After that, it doesn't care, right? And in fact, if you are returning 2 and this 2 is here, you understand that that 2 you are returning, that 2 is not this. Here actually what is happening is that I am returning 2, that is fine, but filter does not care about this value. Filter simply sees that whether it is truthy or false. 2 is truthy, and that's why it has added the original element in here. You have to be very careful with that. Okay, and that's what I was trying to say here, that something like this, 246 will be there because item will treat 0 as falsy. Next, let's see something called reduce. Again, reduce is reduce also takes a callback function. Okay, and what it does is that it takes two arguments, something called accumulator and something called current value. Okay, so let's take a simpler array. Let's say 1 2 3 4 5, and let's write this reduce. And again, reduce takes a callback function, but instead here more commonly, not just one element here, more commonly thing is actually two arguments. The first argument is accumulator, second argument is a current value. Okay, firstly we will not print what is new array and something. Firstly, let's see that what is this accumulator and what is this CURR. Okay, so you see that there is something called initial value, which is optional, and if you don't provide this, then what will happen, we'll discuss it next. But right now we'll see that this callback function is the first. You see this callback function is the first argument of this reduce. The second argument you can provide some initial value, let's say 0. So this thing from here to here is the first argument of reduce. Second argument is 0, let's say, or any value. We'll change that value and we'll see what happens. But how it happens is that reduce starts this with, let's say, in the first iteration it will take 0 as the accumulator. Whatever the initial value you have provided, that value will be used as the value of accumulator in the first iteration. Okay, so let's right now have only one element, 1, and we will try to see that what is printed. So let's say we print ACC and we print CURR, and let's see what happens. We see that 0 1 is printed. So basically this 0 which you provided came as value of accumulator, okay, in reduce. Next, current actually is the elements of the array. So it will right now it is just one element, and that's why one time it is running, but you can very well have multiple elements and it will keep on running. The current will be, let's say, 1 in first iteration, current will be 2 in second iteration, current will be, so whatever is the current item for which it is running, that will be the value of the current. Now what will be value of ACC in the second iteration? We saw that ACC value in the first iteration will be this, whatever you provide here, right? But what will be ACC value in the second iteration? In the second iteration, CURR value will be 2. I know that because it will be the second item for which it will be called, right? But the ACC value in the second iteration will be whatever you return from the first iteration. You should understand it carefully, right? So let's say I return ACC plus CURR. Then in the first iteration, you got 0 1. Then basically you are returning 0 plus 1. Whatever 0 plus 1 value is, 0 plus 1 is 1. That 1 will act as the ACC in the second iteration. So second iteration, ACC will be 1. Okay. And CURR will be 2, the current item, right? Again, this thing is 1, this thing is 2, and I am returning 1 plus 2, 3. That 1 plus 2, final value 3. In the third iteration, ACC will be 3. So we'll print this and see. So you see 0 plus 1, now ACC is 1, 1 plus 2, now ACC is 3, 3, and this in third iteration again the item will be also 3, right? But this 3 and this 3 is obviously different, right? This 3 came from 1 plus 2. This second 3 came from here directly, item. 3 plus 3 is 6. Now this 6 is here. Now this 4 is again the current item in that iteration. 6 plus 4 is 10, and 10. 10 and the last item is 5, and again it is. And finally what is returned? Finally 10 plus 5 is returned. But where the 10 plus 5 has gone? 10 plus 5 is 15, right? Where that has gone? Actually that value which you return from the final array is assigned to the final answer. Final answer means arr dot reduce, the whole thing will return that final value 10 plus 5, the final iteration, whatever. So if you print now, so basically now this is not an array, this is a value. So this sum is this. And if you see, 15 is basically sum of the whole array, right? 5 plus 4, 9, 3, 12 to 14, 115. 15 is the sum of this whole array. So this is the way in which you are summing the array. In other words, this is the way in which I am reducing this whole array to one value. And that reduction is summation in this case. That reduction can be some other thing in some other scenario. But the whole point of reduce is to reduce the whole array into some particular value. So we saw that in map the final answer was an array, in filter the final answer was an array, in reduce the final answer is not an array, the final answer is a value. You can see that the final answer is a value 15, but you have to clearly understand that how that thing is coming. Okay. As we mentioned earlier, the value returned from the last iteration in the final is the final value returned by the reduce method, and you assign it to something, then it goes to that thing. And we took a simple example that if we want to find sum of the some array, then we simply do something like this, then it will work fine, right? And again, you know that yeah, we are writing this just for clarity. Otherwise you could very well write this thing in a one liner, something like you know that this thing is not needed, and if one return is there, then I can use implicit return, right? So I can use something like this. Okay. And you can see that in one line you can find the sum of the array. Okay. Next, next let's see something like this. So let's say 1, 2, 3, 4, 5 is there, and we are trying to reduce it. But here we saw that we are providing here you see we are providing this comma 0, right? What happens when you don't provide this comma 0 here? Okay, so let's go back to the long form to better explain it. So I'm saying that what happens when I don't pass this comma 0? Okay, let's see what is the answer. You see the answer is still 15. But internally a lot of things have changed, and you have to understand that very carefully if you want to understand reduce, because it will come to haunt you if you don't understand it carefully. See, the point is that if you now print ACC and CURR, answer is 15, but now you see that it is completely different. Earlier it was 0, 1. Now there is no 0. It is starting with 1, 2, 3, 3, and see what is it. So all these values which are having this arrow is the value of ACC and CURR printed. Now see what is happening. When you provide initial value, then in the first iteration ACC is that initial value, and the iteration starts from the first element, which means that CURR starts from the first element. You have to understand this, that if you don't provide initial value, then ACC is given the first value. Whatever is the first value in the array, ACC is initialized with that, and the iteration does not start from the first element, iteration starts from the second element. So that's why you see that ACC is provided 1, and now the current is starting from 2, not 1, because 1 is already used, there is no initial value, so that 1 is used as initialization of accumulator, and the iteration is starting from 2. And you can see that earlier 5 times this was printed. Now you can see that it is running n minus 1 times, it is running 4 times only, right? That is because I have not provided any initial value. Now you can see that ACC is 1, CURR is 2, and after that everything is like same. 1 plus 2 is 3, and that 3 is coming here. And again, the next value, first time the value was given 2, next time the value will be given 3, and it will be till the end. So next time the value 3, next time the value 4, next time the value 5, like this. And the ACC will be like as per the reduction logic. So reduction logic is ACC plus CURR, and that's why it is 1 plus 2, and this will be 3 plus 3 will be 6 plus 4 will be 10 plus 5 will be 15, right? So in that manner I have got the same answer, but internally you can see that how things have changed. Okay, and this is important to know. Okay, fair enough. So I think that we are clear here that how reduce works, and you can, instead of this summation, you can write like any logic, whatever you want, right? And that is fine. It's just that you have to understand that whatever you are returning from the earlier iteration will be used in the next iteration as ACC. That's fine. Now let's look at a few more array methods in the next video. So we have already seen a few methods like map, filter, reduce, and in some of the earlier videos we saw that for each, array dot for each, right? So if this is the array, then we can use array dot for each, and we had a callback function where we could print that, right? So we saw that earlier. So this for each is also like map, reduce, filter. This for each is also a method of your available on your array objects, right? Before that we also saw push, pop, shift, unshift, these things. But these are the methods which we have already discussed. In the next video we will start with some new methods which we have not discussed till now.